Hello and welcome to the TES Secondary Maths Resource of the Week number 75 with me, Craig Barton. Now, I know I say the same thing pretty much at the start of every one of these videos, but I absolutely adore this resource. Absolutely brilliant, brilliant, brilliant stuff. It's such a simple idea and crucially such a versatile idea. And I'm going to make the ridiculous claim that I reckon that this can be used with pretty much every single maths topic with every single age and ability. So if you're seeing this A-level maths and thinking, right, I'm going to turn off here because I don't teach A-level maths, please stay with me for a few minutes because I reckon this is such a versatile, simple and important resource. It's been uploaded by Mr. Henchy. It is a Word document and it looks like this. So we've got, I think, 7 kind of prompts or mini activities. And the best way to explain this is just to perhaps look at one. So let's take this first one here. You get 3 coordinates, and the challenge is, can you change one ordinate so that A, B, and C all lie on the same straight line? Now, here's what I like about this. That is such a simple statement, such a simple sounding challenge, but think of all the different ways students might go about this. Some right, some wrong. There could be a gradient approach to this. There could be a y equals mx plus c approach using a bit of algebraic substitution. There could be a y minus y1 equals mx minus x1 approach to it. A sketch maybe. I often find when students have got coordinates that their natural inclination is to bring Pythagoras into the mix, so maybe that could come in there. Loads of similar triangles maybe could even come into play. Loads of different ways of doing it. And that's the beauty of this. So I've used this with a pretty high ability year 12 class when we finished doing our core 1 coordinate geometry work. And we're kind of building up to the exam that's in the next couple of months. And I wanted a way of going back to that coordinate geometry, but without necessarily trudging through the exam questions that they're going to be doing tons and tons of times anyway. So give them this, put them in pairs, see how they get on. And sure enough, with anything like this, don't matter who you do it with, you're going to get a couple who are there saying, I don't have a clue what you're going on about here, I don't know how to start. So that's where I'd say to those kids, well, let's start with a sketch, let's see how far you get with this. What is also lovely is the way that this lends itself so well to further extension work without me as a teacher needing to produce too much extra stuff. So for example, when I was going through this, I had up on the board at the same time a bit of Desmos, so you can plot those points just in Desmos, dead simple, and that might help students start to visualize and start to think about this. But it's lovely this, because what about if you move the blue points? If you want to get the blue point on the same line as the red and greens, or if you want to get the red point on the same line as the blue and green, or you want to get the green point on the same line as the red and green. But it's better than that, because what happens if you want to change the x coordinate of the green to get it on the same line? It's going to be over there somewhere. But if you want to change the y coordinate, it's going to be up here somewhere. So straight away you've got 6 questions for the price of 1, really. But then it lends itself even better to further extensions, because a natural question to ask there is, what's the equation of the line that joins up each of those points? And then once you've then got 3 equations of the lines, what about saying to the students, and where do those 3 lines intersect each other? Or where do those 3 lines cross the x-axis and the y-axis? And if you've got Desmos fired up, whenever students come up with what they think the equation of the line is, you can just type it in and see if it matches, see if it does cross between those points. So loads of different ways to extend it. If you want to turn the question completely on its head, you could say something like, give me three lines where those 3 points are the intersection points of those lines, or something along those lines. Sorry for the pun, something along those lines, to get them thinking as well. But I love stuff like this because it gives me the inspiration to come up with my own prompts for the students to investigate, all starting with something like this. And then a good idea is to perhaps give the students a lesson at this, or half an hour, or whatever you think they need. And then if they're comfortable doing it, get them to the front to share their ways of approaching it, share their experiences with the problem. And that's just one of them. Look at this. Then we get onto a bit of discriminant work here, but it doesn't mention the word discriminant. Can you change one coefficient so it has no solution and one solution? So getting them to think about the discriminant. Does that have it? Is there a unique way of solving that one? Is there only one answer, or are there 2 answers, 3 answers, more than 3 answers? And how would you convince them? And then you get some bit of sector work, bit of factor theorem work, bit of geometric series work. And this just got me thinking that this technique, this change one aspect, this one idea there, has to be such a versatile one, surely, that we can do things there. So I was just picturing 3 fractions in a row, and something like change the numerator change the numerator or the denominator so that this fraction becomes the smallest, or this fraction becomes the middle fraction. just load, and that's just top of my head, and that's probably a rubbish rubbish example. But I just really like this idea of this change one aspect. I think it's such a rich, interesting way of doing things. So there's the resource. If you've used it and you think it's good, then just pop back on and just give a little review. But crucially, if you've used it in a different way, or you've come up with a kind of, you've branched off a little bit further, perhaps into GCSE maths, something like that, hop on here and just let us know and share it, because as I say, I think this could be a runner, this one. I really like the idea of change one aspect, not just as a revision resource, but as a rich extension and consolidation work. So thanks so much to Mr. Henchy for uploading that, and I'll be back with a fresh resource of the week next week. Take care, and bye for now.